the next section we're going to cover is section 1.6, but we've got a little bit of work to do in preparation for that. Because in 1.6, we're going to be taking some graphs, which should be familiar graphs by that point, that we're going to call parent functions. And then we're going to just modify the formulas for things. So for example, y equals x squared, that's the squaring function. That's going to be one of our parent functions. We're going to see what happens if we modify the formula a little bit. So if we get things like y equals x squared plus 5, or y equals x plus 5 squared. Both of these involve adding 5 to the formula. Here we add it after we square the x. Here we add it before we square the x. And we're going to take a look at how these algebraic modifications of the formula affect the shape of the graph. In order to do that, we want to know what the shape of the graph is that we're starting with. So everything that I've got on the board right now is the sort of function that you should be able to graph without having to plot any points. You should just know what that looks like. Now, you might not know that right now. I'm not saying you need to know that right now. I'm saying that by the time we're actually starting 1.6, which we'll be doing pretty soon, you want to have familiarized yourself with these graphs so that you're able to say, oh yeah, I know exactly what that looks like, and you can plot it without having to create a table of values. Now, how are we going to get there? Well, we're going to get there by creating a table of values. In general, when I don't know what a graph looks like, the best tool that I have is to just plot some points and then connect the dots. Okay? Hopefully using a little bit of logic to make sure that if I see a pattern, I confirm that that pattern kind of makes sense for that particular formula. So that's what we're going to do. So what I've got here is this is the homework to prep for section 1.6. So this is posted on Canvas. And the first functions we're going to talk about are lines. I'm going to just, in this video, go through a review of linear functions and what their graphs look like. After this video, you should then complete the rest of this worksheet. Basically, for each one of these functions here, I give you a table of values that I ask you to fill in, and then plot those points, look for patterns, and connect the dots to get the graphs of those functions so that you can familiarize yourselves with those. So, in this video, we'll work through linear functions together. Once this video is done, complete the rest of this handout working through the squaring function all the way down to the reciprocal function, and then we'll review those graphs together in the subsequent videos. All right, so for linear functions, basic equation of a line, if I have y equals mx plus b, that's a nice form for an equation for a line. This number m is the slope of the line, and the number b is just the y value of the y-intercept. Let's just take a look at an example. Let's suppose that y was equal to 2x plus 3. Let's pretend I didn't know this was a line, so I was just going to create a table of values, x and y values. So, if I plug in 0 for x, I would get y equals 2 times 0 plus 3. That would be 3. So, I could plot the point 0, 3. And I can actually see, anytime I have something that looks like this, if I plug in 0 for x, I'm just going to get b. So whatever number is by itself is always going to be the y value of the y-intercept. Notice I was careful about how I stated that. I didn't say b was the y-intercept, because the y-intercept I want to remember is a point, not just a number. So that would be the point 0, 3. Now, if I plug in 1 for x, I would get y is equal to 2 times 1 plus 3. That's going to be 5. So I could plot the point 1, 5. And if I plugged in 2 for x, I'd get y equals 2 times 2 plus 3. That's going to be 7. I could plot the point 2, 7. And it really does look like those points lie in a straight line. And in fact, they always will. If my formula is just some x's plus a number, I'm always going to have a line. And the shortcut is to use this number that we call the slope. Slope, which is often denoted as an m, is slope, it's always just rise over run. So if my slope is 2, I probably want to write that as a fraction. I can write that as 2 over 1. That's just telling me that if I'm at a point on the line, if I go up 2 over 1, that's going to take me to another point on the line. Up 2 over 1 takes me to another point on the line. So in general, if I'm graphing a line, I basically just need 2 points. Here I went a little above and beyond. I graphed 3 points. If I know it's a straight line, as soon as I've graphed 2 points, that's going to uniquely determine the line that I would want to draw. So let's try just a couple more. Let's say I had y equals -1/2 x plus 5. Now, I'm not going to bother with a table of values here. I'm able to say that that's the y value of the y-intercept. So I can go up 1, 2, 3, 4, 5. There's the point 0, 5. That's my y-intercept. And then my slope is -1/2. Now, I do need to be careful when I have a negative number. If I have a negative number, I can write the negative sign in front of the number like that. Or I can associate it with the top. So I can sort of put it in front of the fraction. Or I can associate it with the top. Or I can associate it with the bottom. Okay. For using it as the slope and thinking of that as directions to get from one point to the other, it's not super helpful to have it in front like this. Usually what I'm going to do is associate it with the top of the fraction. So that would tell me from this point, I want to count down 1 over 2. It's down because that's a negative. Notice, if I had viewed the slope as being +1 over -1/2, I would have counted up 1 and then to the left 2. Now that would have taken me to a different point, but when I connect the dots, I'm going to get exactly the same line. So it doesn't matter whether I associate the negative with the top or the bottom of the fraction, but it is helpful to associate it with one of those. Okay. All right, excellent. So if I'm graphing a line, I'm basically just going to plot the y-intercept and then use the slope as directions to get to another point on the line, and then I can play connect the dots. Useful to know that if the slope is a negative number, my line will be going down as I go to the right, and if the slope is a positive number, my line will be going up as I go to the right. Now, if I have something like y equals 2, that counts as a line. Notice that's the same as 0x plus 2. So the slope is just 0. And if y is equal to 2, we actually call this a constant function because the y value is constant. It's not changing. So of course the y-intercept is 2, but then y isn't changing. I'm not going up or down at all, but I can go left or right as far as I want to. So a constant function, which is a line with slope 0, is just going to be a horizontal line. All right, and then there's one special line that's on your worksheet, y equals x. That's called the identity function. And that's simply because whatever you plug in is exactly what you get out. If I plug in 5 for x, I get out 5 for y. Okay. All right, notice if I wanted to, I could write that as y equals 1x plus 0. So it's going to be a line through the origin. If I'm not adding any number to x, that's equivalent to adding 0, which means that the y-intercept is going to be at 0, 0, or at the origin. And then the slope is 1. Anytime I have a whole number for the slope, I can write that as a fraction, 1 over 1. So that's going to say I go up 1 over 1, connect the dots. And so basically the identity function is just this line that passes through the origin making an angle of 45 degrees with the positive x-axis. Okay. Now, that's a fairly quick review of lines. If you feel like you need more of a review on lines, let me point out, where are they? Section 1.4, sorry. it's on your homework for this preparation for 1.6. Section 1.4 does a review of lines. I'm guessing a lot of you are going to be comfortable with these, but some of you might feel like you need a little bit more practice with those. So 1.4 is a good place to look, and I'm more than happy to spend additional time reviewing linear functions and graphs of lines with you in office hours or by appointment. So if you do feel like this wasn't quite enough of a review of that, feel free to let me know, and I can make some suggestions for where to look and also spend some time working through that with you.